bear with me. And here we are told that the Golf Association requires that golf balls have a diameter that is 1.68 inches. I'm just going to jump here to the end. Do the golf balls conform to the standards? And we're going to use an alpha of 0.05. So for this exercise, let's just notice that the null hypothesis is on a population mean, and it is always in the form mu equals. Again, please refer to the other videos. 1.68 and to your reading. Now, since we are not given any sort of, do the diameters, are they bigger, are they smaller, that sort of thing, then we're not given that kind of direction. So when you're not given any sort of direction, we always use a two-tailed test. So here we will choose not equals to 1.68. Okay. Yay, I got it right. So now we got to find the test statistic. So if you're given a data set, and this is our data set, which means then we'd have to compute X bar, and then we'd have to compute S, which is fine because we can use technology to do that. But to get the test statistic, once we have X bar and S, then we have to throw everything back in that formula. Why don't we let technology assist us? So I'm going to click on this box. So again, when you have data, click on the box, open in StatCrunch. All right. So again, bear with me. I'm going to try to parallel my windows here. All right. Hey, it worked. Hallelujah. Okay. I'll click done here. So that test statistic now. So let's just go ahead and come over here to stat. We are doing a T statistics, one sample, and in this case we've got data. So we need to make sure we choose data. So here we'll choose our diameter. There's our data set. So mu equals, again, this is the information we're going to plug in. So 1.68. And, don't need a slash in there. And mu is not equal to, so that automatically filled in. So this is all we need. So basically, out of all this other stuff, there's a whole bunch of other stuff. We don't need that stuff, so let's just go ahead and click compute. Oops. And so here we are. All right, so our test statistic right here, which if you'll recall the formula that was used, kind of a doozy. So notice that we have this thing typed in for us. So our test statistic, again, note round to 2 decimal places. So make sure you use your rounding. So 0.81. All right, so now we're asked to find the p-value. So let's just recall, since this is a two-tailed test, you would have to compute the upper tail, double it based on your reading. So 2 times whatever that p-value is. But notice here, we already have that taken care of for us. So 0.436. So let's just go ahead and type in 0.436. So notice that the StatCrunch really does, knock everything out for us. As far as the computation is concerned, we still have to make sure that we can interpret everything correctly. So notice that our decision-making criteria at this point in time, our decision-making says that when it comes to p-values, we reject the null hypothesis for small p-values and fail to reject the null hypothesis for large p-values. So in order to get small and large, we compare the p-value to the alpha level. And notice that the p-value is greater than the alpha level. So notice that since the p-value is greater than the alpha level, that means we will reject the null hypothesis. That is our decision. So now the question is, what does this mean? So there's the decision, and then there's the interpretation. So we fail to reject the null hypothesis because the p-value is bigger than the alpha level. We fail to reject the null hypothesis. So what does this mean? When you fail to reject the null hypothesis, that means that the data does not show enough support for evidence on the alternative. So when you fail to reject the null hypothesis, all that means is there is not enough evidence in the data to support the alternative. That's all it means. So notice that since we failed to reject, here's our decision, do not reject, and notice we have another one, do not reject. So notice that when we do not reject, that means that there is not enough support in the data, or not enough evidence in the data to support the alternative. So notice there is not sufficient evidence to conclude that the balls do not conform, or we have do not reject, there is sufficient evidence to conclude. So since there is not sufficient evidence, we will go ahead and choose A. So do not reject is our decision, and this is our interpretation. There is not sufficient evidence. So we'll go ahead and check our answer, and there we go. Okay. So I'd like to go ahead and take a look at one more. Maybe take a look at this one. Okay, so this one here we have, let me go ahead and click here. I want to close this window. Okay, so now we're back here. All right. So a random sample of size 15 is drawn, normally distributed. So we have a sample mean of 29.8, sample standard deviation 6.3. So determine if the population mean is different from 24. Well, let's just note that mu and the null is always in the form mu equals 24. In this case, we are now asked, is the population mean different? So we will put mu is not equal to 24. All right, we'll go ahead and check our answer here. All right. Good job, guys. Good job. All right, so now we need to compute the p-values. So again, this is where we'll come over here, fire up our StatCrunch, and let StatCrunch do all the gory work for us. So I'm going to parallel my windows. All right, so now we'll just come over here to stat. Again, t-stats, and one sample. In this case, we'll do with summary. So now we have a sample mean. So notice here we're given a sample mean of 29.8. We have a sample standard deviation. Sample standard deviation is 6.3. And our sample size, we are told our sample size is 15. Now before I move forward, let me just note that I've seen a lot of mistakes where people will put mu. So notice we are told that the population mean is different than 24. That's mu. Sample mean is x bar. Please make that note and do not make that mistake by putting mu in for x bar. All right, so now we have that mu equals 25. Oh, I'm sorry, 24. And mu does not equal 24. So again, there's nothing else to do. So notice here our p-value is point. So we want to go 3 decimal places. So make sure that you get this 0.003. Check our answer. Did a good job. And again, based on our earlier exercise, notice here the p-value now is way smaller. So alpha is 0.01. Our p-value is 0.003. So not only is our p-value is a lot smaller, so this indicates that there is really strong evidence to support the alternative. So notice here, notice our decision is to reject the null, and the interpretation is that there is sufficient evidence to support the alternative hypothesis. Does not mean we've proven the alternative. It just means there's support. There's evidence to support it. So here we're going to reject. So do we reject because the p-value is bigger, or do we reject because the p-value is smaller? And we always reject when the p-value is smaller. All right, so that concludes this video, and I hope you found that this video helped you out. Thanks a lot. See you in the classroom.